Q1 limits. Now let me consider fx equal to x squared. So what is the value of fx when x approaches 2? Please note that we consider when x approaches 2 but not x exactly equal to 2. Limit examine the behavior of a function fx as the value x gets closer and closer to number of a, but not equal to a. For example, limit x approaching 2 for function x squared. So given that fx is equal to x squared, so then we need to find the limit for x approaching 2 from right. So when we try to substitute values of x, like 2.1, 2.01, and etc., we find that all the values of fx is much more nearer and closer to 4. For the same function, we try to find the values of limit of x squared for x approaching 2 from left. When we try to substitute values from x equal to 1.9, 1.99, and so on, we find out that the values of fx is also approaching to 4. So that we can say that from left hand side and also from right hand side, when x approaches 2 for function x squared, all of the fx values is approaching 4. So then we can say that limits of fx for x approaching 2 for function x squared is equal to 4. This is actually the concept of limit. If the function f approaches a number L when x approaches a, then we say that the limit of fx when x approaches a is L. Intuitively, limit can be evaluated by substituting x equal to a into the function. These are the basic properties of limit. So, we just need to substitute all the value that's stated from the limit below. So, for example, x approaches a, we just need to substitute the values of a. But for the first properties, we can see that limits x approaching a for c, say c is a constant, then the answer is the constant itself. These are the examples for the first properties. Then for the limit x approaching a for function x, we just need to substitute the values of x under the limit into the function x given. The third property is limits of x approaching a for function x to the power of n. So we just need to substitute again the value of a inside the function and write down or calculate and finalize the answer for the limit. This is the fourth properties. We just can split everything up. For instance, in the example, we can write down limit x approaching -1 for function x squared plus x can be written as limit x approaching -1 for x squared plus limit x approaching -1 x. Same goes for example B. We can split it up into limit x approaching -2 x squared plus limit x approaching -2 5x minus limit x approaching -2 9. This is the fifth properties. So for instance, if you have a multiplication of two functions, you just can split it up also. It can be written as limit x approaching 2 x to the power of 4 multiplied by limit x approaching 2 for function x minus 1. Same goes for b. It can be written as x approaching 3 for 5 plus x multiplied by limit x approaching 3 for x squared minus 3. These are the 6 properties. So when it is the two function is divided by each other, we just can split it up. And just make sure that limit x approaching a for function gx is not equal to 0. So that's our example. The last property is limits of x approaching a for any constant multiplied with a function. Actually, we can split it like this. Look at the example. So that's what we should recall for 8.1. Alright, until the introduction of the properties, we can solve question number 1 to number 2 in your tutorial question sets. So let's say we look for a few examples from related question for guardian in order to you for achieve the objective. So let me see question number 1. I'll pick question number 1A. They ask you to evaluate the following limits. It's given to you limit x approaching 2 for function 3x plus 7 minus 4x squared. So, in order to solve this one, since they just ask you to evaluate, we just can substitute the value x approaching 2, the value 2, inside the function. So, you'll get 3 times 2 plus 7 minus 4 times 2 square. By pressing your calculator, your final answer would be -3. So then, by using properties, let's solve question 2. I'll pick question 2A. Before that, let's look at the information given. They give you limit x approaching a for function fx is equal to 2. And also, limit x approaching a for function gx is equal to -1. They ask you to find limit x approaching a for function x times fx. So by using properties, we can split this into limit x approaching a function x multiplied by limit x, a limit for x approaching a for function fx. It's given to you that limit x approaching a for fx is equal to 2. So we just need to substitute the value inside. You're left with limit x approaching a for function x multiplied by 2. Recall that if we have something, function, and also x is approaching of a number, we can just substitute the number inside the function. Then you'll have a multiplied by 2. So the final answer would be 2a. You can complete the other question by yourself by recall back all of the properties. Next, how about if you have something in rational function? So limit of rational function can be found by substituting the value of x when the denominator is not 0. So make sure the denominator is not 0. So we can just substitute the value that given x approaching to 2 inside the function. Then we can calculate it by ourselves. How about if the denominator is 0? If the denominator is 0, it will give you something else. So what should you do is you just need to either factorize it or you can multiply it by conjugate if it is involving series. So for this kind of question, we can look at question 3 and question 4. It is involving rational form. Okay, we'll start with question 3. Let's say I'll pick 3a. They ask you to find the following limits. Question 3a gives you find the limit for x approaching, oh, it's not x, sorry. Let's look at question 3a. For example, in your tutorial question, okay, they ask you to find the limits for limit of r approaching 0 for function 2 plus r, the whole thing square, minus 2 square over r. So for instance, if we try to substitute the value of r approaching 0, so we need to try to substitute 0 inside the function, you'll get 2 plus 0 square minus 2 square over 0. You'll end up to get 0 over 0, which is, this is not valid. What should you do? So either you need to solve it by using factorization or multiplying with its conjugate. So in this case, we'll pick factorization. So we'll start with the limit equation, limit r equal to approaching 0 for function 2 plus r square minus 2 square over r. What should you do first is you need to expand the function. So you get limit r approaching 0. You expand the numerator. You'll get 4 plus 4r plus r square minus 4 divided by r. So by simplifying it, you'll get r square plus 4r over r. Okay, so by factorization, you need to factorize the numerator. You'll get r plus 4 over r. Here, there is some cancellation happen. You're left with limit r approaching 0 with function r plus 4. After doing the factorization and cancellation, you just need to substitute the value of 0 inside the function left. So you'll end up with 0 plus 4. So the final answer for the limit is 4. We'll continue to discuss for question 4. So for question 4, the information given to you says that if fx equal to x cubed, then we need to find the limit for x approaching 3. The function given is fx minus f3 divided by x minus 3. So what should you do first is you need to find what is the value of f3. So fx is equal to x cubed. So if you want to find f3, you just substitute 3 inside the function. Okay, you'll end up with 27. So then you'll have limit x approaching 3. So fx minus 27 over x minus 3. So don't forget, you have fx here. You can substitute fx with the original function given. So your fx can be substituted into x cubed. So this is your full function. So what should you do next? If you try to substitute, for instance, let me try substitute here. Okay, so for limit x approaching 3, x cubed minus 27 over x minus 3, and I'll try to substitute the value of x there. I'll end up with x cubed minus 27 over 3 minus 3. So it's become 0 over 0 case again. So you either need to factorize, or you either need to multiply by conjugate. So here you cannot multiply by conjugate since you don't the function is not involving cert. What should you do is you just need to factorize. Remember back, you already learned from your long division in topic 6. You can do long division here. You have x cubed minus 27. So you need to divide it by x minus 3. So x squared, you'll get x cubed minus 3x squared. So minus, then you'll have the remainder become 3x squared minus 27. Okay, and then plus 3x squared, 3x only. So you're left with 3x squared minus 9x. Okay, so you'll end up with 9x minus 27. Again, you need to do something with it. Plus 9. Okay, you're left with 9x minus 27. Okay, so then you have here the remainder is 0, right? So then you can write down limit x approaching 3. The factor will be x minus 3 and x squared plus 3x plus 9. Okay, and then the denominator is x minus 3. So here it can be cancelled out. You're left with limit x approaching 3. And the function left is x squared plus 3x plus 9. So just substitute the value. You'll get 3 squared plus 3 times 3 plus 9. Hence, you'll get the answer as 27. Now we continue our discussion about one-sided limit. So what is one-sided limit? A one-sided limit can be either be a left-hand limit where it is approaching a value from left, or right-hand limit where it's approaching a value from right. So for instance, if I can summarize it in sentences, a right-hand limit is the limit of fx as x approaches a from the right-hand side to of a where it is equal to a value L. And a left-hand limit is a limit of fx where x approaches e from the left side of a where it is also equal to a number. Sometimes the value of L and the value of M wouldn't be the same. For example, if we refer the graph, it's not the same. Then from the right hand limit and left hand limit, we can show there is existence of the limit. What should we say about existence of limit? If the limit from left hand side and also right hand side is the same, then the limit of fx approaching the value would be L. See, if from left hand side it is equal to L, and right hand side it is also equal to L, then the limit of x approaching the value will be L, where a and L is a real number. Therefore, the limit of fx approaching for x approaching a is exists. Alright, for example, let us try question 5, question 6, 7 and 10 from your tutorial question. So I'll pick a few and we'll solve it together. So we'll start with question 5. Okay, I'll pick question 5a. So they ask you to find or to determine the limit of fx for x approaching a from right, from left, and also x approaching a. So for question 5a, they give you a function fx equal to, so it is a piecewise function, 3x squared minus 6 for x is less than 2, 8 minus x for x is greater or equal to 2. They ask you to find limit for x approaching a, where the a is equal to 2. So let's start with find the limit for x approaching a from right, from left, and then we find the limit for x approaching for the value of a. So first thing is we draw a line number to recall where is the function from left and from right. So for x is less than 2, so the function in the left of 2, so the function here will be 3x squared minus 6, and for the right one is 8 minus x. So for the first one, I'll try to find the limits of x approaching 2 from right. Then the function from right is 8 minus x. So what I do next is just I need to substitute 8 minus 2, there I get 6. Okay, then I'll find from left, x approaching 2 from left. So the function from left is 3x squared minus 6. So I just need to substitute 3 times 2 squared minus 6, then there I also get 6. So hence, since my limit of x for 2 from right, fx, is exactly equal to limit x approaching 2 from left for function fx, hence I can say that therefore limit x approaching 2 for function fx is actually it's equal to 6. Next, we are going to continue for question 6. So it's given to you a function fx is equal another piecewise function. So x squared plus 1 for x is less than 0. Third 1 minus x squared for x in between 0 and also 1. And 2 for x greater or equal to 2. Then we need to determine limit x approaching 0 fx and also limit x approaching 1 fx. So here we have two different values. So we write down or we draw the line number. Here we have a few value. Oh, so sorry. Okay, so we have 0 and also 1. We just need to identify. So for x is less than 0, the function will be x squared plus 1. X in between 0 and also 1, the function is third 1 minus x squared. For x is greater or equal to 1, the function is 2. So then we'll need to find for limit x approaching 0 first. So we'll try to find from left and right of 0. So limit of x approaching 0 from right. So function from right is third 1 minus x squared. substitute the value, I'll get 1 minus 0 square third, then the final answer is 1. Okay, and from left, limit x approaching 0 from left. So 0 from left, the function is x squared plus 1. So substitute, I'll get 0 squared plus 1. So the answer is also 1. From here we can say, since both are same, since limit x approaching 0 from right for fx is exactly equal to limit x approaching 0 from left for the function fx, therefore limit x approaching 0 for fx is exactly equal to 1. Okay, then we'll find for the left one, the another one for 1. So limit x approaching 1 from right, the function is 2, so the answer is 2 by properties. So, and then limit x approaching 1 from left, the function that is 1 minus x squared, substitute the value, I'll get 1 minus 1 square, the whole thing third. Here, the function, I got 0. So from here, it's not equal. So since limit x approaching 1 from right for function fx is not equal to limit x approaching 1 from left for the function f or for fx, therefore we can conclude that limit x approaching 1 for function fx, because it is not same, then it is not exist. So the last example that we're going to discuss involving existence of limit is question 10. So they give you a function of fx, which is, it is a piecewise function. Okay, so from this piecewise function, we can write down or draw your line number. So it's involving 0 and also 2 for values of x. So the function involved for x is less than 0, the function is x cubed minus c. Between 0 and 2, the function is ax squared plus b. And for x is greater or equal to 2, the function is 2x plus 2. So for part 1, they give you, they ask you to find the value of c, and they give you limit x approaching 0 from left for function fx is equal to negative 2. So from our line number, we can say that the function that involving from the left of 0 is x cubed minus c. So just substitute inside. Limit x approaching 0 from left, the function will be x cubed minus c should equal to negative 2. So we just need to substitute the value inside the function. So 0 cubed minus c is equal to negative 2. Hence, we can say that c is equal to 2. So part 2, okay, they ask you to find the value of a and b, but they give to you that limit x approaching 0 of fx and limit x approaching 2 of fx is exists. So what the means of exists? It's mean that the limit from left and from right of 0 and also 2 should be in the equal or same value lah. Alright, so we'll start with limit x approaching 0 for fx is exists. So therefore, from there we can conclude that limit x approaching 0 from left for function fx should be equal to the limit of x approaching 0 from right for function fx. Okay, and then we just need to substitute the function involved. So here you get limit x approaching 0 from left, the function is x cubed minus c. And from right, limit x approaching 0 from right, the function here is ax squared plus b. So by substitute the value, you'll get negative c is equal to b. But recall back from part 1. Okay, we'll get C is equal to 2. So substitute. There you have therefore B is equal to negative 2. You have the value of B already. Okay,